In this lesson, we are going to recap on scatter graphs and start looking at terminology that we would use doing bivariate data. So first of all, I want you to think about what the scatter graph shows about the relationship between the height and weight of 20 year 11 boys. So have a little think. Awesome. The language that we would use, we would say, as the height increases, and we are specifically looking along our x-axis, as the height increases, the weight increases as well. The reason that we'd say the height first, and the height would be on the x-axis, is because weight is more likely to be affected by height than the other way round. Just because you get heavier doesn't mean you're going to get taller, whereas as you grow and get taller, your weight should increase with fat. This is called a positive correlation. As whatever it is on the x-axis increases, so does the y. And you wouldn't say x and y though, you would say as height increases, weight increases too. What does this scatter graph show? So thinking about that, you can pause and have a little think. It shows that life expectancy decreases as the number of cigarettes smoked increases. So as my x values increase, my y values decrease. This is called a negative correlation. As whatever's on the x-axis increases, whatever's on the y-axis decreases. Again, you won't say x and y, you will use the words and the language of what is given. Scatter graphs can show a relationship between two variables, and the relationship is always called a correlation. Correlation is a general trend, and some data items will not fit this trend. They are often called outliers, or extreme values is another word we may use for that. Scatter graphs can show a positive correlation, as one variable increases so does the other, or a negative correlation, where one variable increases the other decreases. Sometimes there is no correlation, zero correlation. There's no relationship between the variables, and that would be if you just had dots all over the place or scatter all over the place, and there is no relationship between the two variables. The correlation can be weak or strong. So you are going to decide which of these is true for the following graphs. Okay, so have a look at those, write up your answers. So pause this, write them up, and then have a little think. Oh, we'll go back. Okay, hopefully you've had a little think. The first one, hopefully you said, was a medium to strong negative correlation. B, I would say there was no correlation there. There's just dots all over the place. C is a weak positive correlation. D is a relatively strong positive correlation. E is a strong negative correlation, and F is a medium to strong negative correlation. How are these variables correlated? Number of pairs of shoes and the GCSE grades. Do you think GCSE isn't something that you do now? Let's say NCEA grades. Do you think the number of shoes you own is going to have any relationship to your grades? So hopefully you'll have no correlation for that one. The line of best fit is drawn by I, so that there are roughly an equal number of points below and above the line at all points. So it can't just be there's the same amount above and below, but one lot is on this side and the other lot is on that side. They have to be above and below at all points. Now, when you use graphing apps, sometimes their line of best fit includes extreme values, which we, when we're doing it by eye, wouldn't include. So our one is often going to be a lot better than the one done by the app. So it is good to know how to do these yourself. So if I have that one over there, can you see there is the similar amounts on either side? Now, if I just did it that way, you could say, oh, there's the same amounts above and below, but this half would be on the left and that would be on the right. So it has to be through the middle of the data. So weak positive correlation. Okay, so hopefully notice that the stronger the correlation, the closer the points are to the line. That is something that you would need to write down, state what you can see. If the gradient is positive, the correlation is positive. If the gradient is negative, the correlation is also negative. When drawing the line of best fit, remember the following points. The line does not have to pass through the origin. It could start anywhere. For an accurate line of best fit, find the mean for each variable. Actually, for the accurate line of best fit, use your eyes and make sure it goes through the middle. The line of best fit can be used to predict one variable from another. It should not be used for predictions outside the range of the data used. So if you have some variables, do not predict beyond what you have actually got in front of you. And the equation of the line of best fit can be found using the gradient and the intercept. You do not need to find that for this course.